All right. I will begin. So, I gotta get a whistle. All right, I'm just gonna pray. Dear Heavenly Father, we thank you for this day. I thank you. Thank you. Thank you for this day. I thank you for these students. And I pray that you be with us today. Help us to glorify you in what we do. And I just pray we use this time for your glory, Lord. In your name I pray. Amen. Let's see here. All right, so anybody not have their test already? Let's see here. What section? This is section 3, right? 2? Are we 2? This is 2. Oh, if it says it on top hat, then it must be. I cannot argue with top hat. Well, so who here does not have their test? Name? Did you take it?
I did. I took it over Zoom.
Took it where? Over Zoom? Oh! I haven't graded yours yet. I'm sorry. I forgot about that. Yeah.
I'll take it.
Well. I had everything all nice and organized last week, and then something happened. Let's see here. Well, this is not your...
Thank you.
That's the quiz, actually. What was the name again? Oh, here you. I found it. There you go.
Thank you.
Anybody else? Name?
Davis.
Ah, yes, here you are. There you go. Anybody else? All right. So today, we're going to continue looking at graphing by transformations. I made you guys a worksheet for today, which we'll be following along. First of all, I made you guys a handout, and this handout summarizes the things we know. So I'm going to give you more than you need. Just take what you need and pass it back, and then take what you need and pass it back. Just one sheet there. So this first sheet I'm passing out, it has the standard examples we went over last time. Just a quick little picture of them. And also, I have a worksheet for us to fill out. But I think before I even do that, I'm just going to spend a minute with the projector here. Everybody get one? Where's there extras? There should be extras. So again, take one and pass it back. Take one and pass it back. Where are my extras? Thank you. Take one here and pass it over, okay? Where was the extras? Thank you. So let me, so some of you have graphing calculators, which are fine for like homework, but I think there's a better way. I mean, I don't think there's a better way. I know there's a better way. And a website I've become fond of using, it's called, no, not Nevermind. Let's see here. Desmos. This is In fact, I write notes for like my calculus class. In my calculus notes, current version, I actually have links to. Come on. Okay, it's there. All right, so there we go. So we can go in there. And so this is a free website, and it's very nice. You can create an account there for free, save your work. You can take screenshots of graphs here. There's all kinds of things you can do. But I just want to show you just some basic, really neat stuff we can do with this. For example, y equals x squared. There it is, right? Nothing too surprising there, right? But suppose you want to add a constant. What's that look like? So I say plus c, I add a slider c, right? And then what I can do is I can take this slider and I can move it around. And as you can see, when c is negative, it goes down. When c is positive, it goes up, right? And if I was even really bored, I could animate it. Whee! There you go. In contrast, we could say put the c, like that. See, so what happens if I add c to x plus c squared? What happens then? See what happens? It moves it left and right. Notice that when we put c, so right now c is 3.9, it shifts y equals x squared 3.9 units to the left, right? If we put, on the other hand, negative, it goes to the right. So this is what's described in your transformation sheet here. I've got like number 1, shift up by c units. Number 3 rather, shifts right. Or number 3, I'm illustrating number 3 and 4 here with this picture. I neglected to say something on the sheet, which I meant to write on the sheet. I just realized. I am assuming for 1, 2, 3, and 4 that c is a positive number, just to make it. You notice I have like 1, 2, 3, and 4. You could condense to just 2 things where you allow c to be positive or negative, but I think it's helpful to separate positive versus, left versus right, and just think about c being a positive number there. So that's what I did. Let's see here. We can do other things. Let's see here. Let's try something a little bit more interesting, like, I don't know, x cubed plus 3x squared minus 7x plus 1. There you go. So this is a cubic, like that, right? What happens if I add c to that? It just does what? It allows us to, oh, come on, go back. It's just going to move it up and down, right? Adding a constant to a graph shifts it up and down. Now, if I was also to be a little bit more adventurous here and replace x with, say, x plus a, right? So I'm just taking everywhere there's an x and I'm replacing it with x plus a, right? Stupid keyboard fingers too big. Oh, come on, what are you doing? Stop that. Yeah, it's doing that to me, but I don't know why.
You have an extra pencil.
Yeah, I see that. I wasn't asking for it. It just came. Thank you, though. There we go. Now I have 2 sliders, right? What happens if I animate both of them at the same time? Ooh. So now we're shifting left and right and up and down, right? So if you have 2 parameters, you can see all kinds of different cases here. Exciting, yes? Let's see here. What else could we graph while we're on this? How about, will it do absolute value? Let's find out. Let me turn this one off. Y equals absolute value x. And I'll just click that one to make it go away. So there's the absolute value of x. Of course, if I add a here, that's going to shift it around, right? Left and right. What happens if I put a c out front? So now I'm doing c times the absolute value of x plus a. What's it do? So the a shifts it around, right? If I move the a, it's going to shift it left and right. What's the multiplication by c do, though? See, moving a shifts it left or right. How about the c, though? Stretches or compresses, right? So since c is positive, it's if c is positive and less than it. I think it's helpful to have a reference point. So let's put y equals absolute value of x as a reference point. So there's y equals absolute value of x, right? And I'll make it line up. I'll put a to 0. There we go. So what happens with c? If c is positive and greater than 1, it stretches it out, right? It stretches it vertically. But if c is less than 1, it is going to smush it, right? It compresses it vertically. And if c is negative, what happens? It flips it over, right? So a negative number is going to reflect across the x-axis there. Let's see here. What else can I show you? Let me put this away here. Get out of here. Get out of here. All right. So what if we had y equals to x to the 4th? Actually, you know what? Here's another thing we can do. Check this out. So if we put a here, we can actually look at the different cases, right? And this was actually going to give me some other things we haven't even talked about, like what does x to the 1.2 power look like? You know, let's stop. Let's fix that. I'm going to put the step size as 1. All right. All right. So here we go. That's x cubed. Here's x squared. Here's x. Here's x to the 4th. Here's x to the 5th. Here's x to the 6th, 7th, 8th, right? So anyway, we could try things like looking at x squared and looking at x to the 4th and looking at x to the 10th all at once, yeah? Let me zoom in a bit. So that was the picture I was drawing by hand last time, right? Like I said, the higher powers get smushed out between -1 and 1, and then they grow faster once you're past 1. Anyway, my advertisement for Desmos is now done for you. My point to you is if you're curious about what something looks like, you can easily open up this website and look at it, right? But on the test, we need to learn a method that stands by itself, right, without this. This is good for checking work and, you know, also for applied classes where you have a formula, you just want to see what it looks like. It's a great resource. So, any questions? Again, just www.desmos.com. So. All right, so let's get started on our worksheet. So, example 1. So I'm going to work on filling in the graphs here. So we're supposed to graph y equals to the minus the absolute value of x plus 3 minus 2. So what's the basic graph that we want to start with? Absolute value, right? So I'm going to go ahead and anticipate where I'm going here. So I've got It's going to be a 4-step process, right? It won't always be 4 steps, but I've made some examples with 4 steps. So we start with absolute value, just like you said. What absolute value looks like this, right? Now, if you want to make a good graph, it's helpful to track, let's say, 2 or 3 points, right? So if I track the point, let's say the origin, and what are 2 other good points to track if I want to be careful? 1, 1, good idea. 1, 1, and minus 1, 1, right? So those are 3 good points to track. Now what's next? So this is just, I'll write down here. We're looking at y equals absolute value of x. So I said step 2, let's shift left 3 units. So shift left would be x plus 3, right? So we take these points, we shift them 3 left. So not quite to scale, but something like this, right? Right. So there we go, shift left 3. Then what? Said reflect over the x-axis. Yeah, because of the negative in front. That will flip it upside down. Now I should keep track. I'm going to keep track of. I'm going to label the vertex point at least. Okay. So that was minus 3, 0, right? And that point is still in the picture over here. This would be negative 2, 1, and this guy would be, that's a good question, minus 4, 1. So you just take these and shift 3 units to the left, right? I mean, correct. Shift 3 to the left. 1 minus 3 is minus 2. Minus 1 minus 3 is minus 4. So, yep.
What was the point on the very left?
This one?
Yeah.
That's minus 1, 1.
Okay.
Is it in the glare? Or am I just, it's just too small. Sorry. Okay, so putting a minus out front flips it upside down like that, right? And so the points we were tracking, minus 2, 1 now flips to minus 2, minus 1, right? And this point flips to, minus 4, minus 1, right? All right. And what's up next? Now we do what? Oh, now we shift down 2, right? So we shift 2 units down now, and that's going to give us the final product, right? Y equals to minus the absolute value of x plus 3 minus 2. And so shifting down to my vertex, my corner point here on the absolute value graph, shifts down to like minus 3 comma minus 2, right? And then the other 2 points shift to minus 2, minus 2, and this one shifts to, I'm sorry, I can't do math. I have to shift down 2, right? So minus 2 is what? Negative 4, yep. And this one, I think it's the same, right? Negative 4 again. So minus, wait a minute. Negative 4. I was fished in. Negative what? We're shifting down 2. So minus 1 shifts down to minus 3. So, all right. Now, obviously, if we don't follow the 3 points, it's a lot faster, right? Like a lot of the time and energy we just spent was tracking those 3 points. But if you want a quality graph, you need to track some points, right? If you just want to sketch, right, you don't need to track the points. Maybe it suffices to track, let's say, 1 point if you just want a kind of a quick sketch, right? Any questions? Yep. It depends on the instructions. If I say, please track 2 points or something, then yeah. But I might just say find a quick sketch of this using transformation of graphs. And then I will probably give you this exact same four-part squares like on your worksheet and say, use these templates to track the graph, yeah? The idea here on the board is that these fit in the 4 squares that you have in your example 1. Like you can draw these like in here, right? Like this one goes in the first one, this one goes in the second one, this one goes in the third one, the fourth one is the answer. Right. Now, I think it's going to get a little bit crowded to put all the numbers in here, right? So, okay, let's go on to example 2. There's another question you should ask, right? The better question to ask is like, are you going to give me the order of the transformations that you have to do? Like, I'm not, right? That's something you need to be able to figure out. Okay, so I am, in these examples, I'm giving you examples, but really part of the thing you should be asking yourself is, how do I figure out what transformations I should do? And the answer to that really is just experience and looking at the formula. There's not a unique answer, by the way. Like for example 2, I'm looking at y equals the square root of 9 minus x minus 3, okay? And this one, we're just going to track 1 point to keep things a little bit simpler, okay? So, all right, so we start out with what? What's the basic graph here? I think it's square root of x, right? Mm-hmm. So that's what I start with. So think of it, if you think of this as pottery, this is like your lump of clay, okay? And I'm just going to track the origin because, that point right there, okay? Now, what's next? What did I do? I shifted to x. So actually, I should mention, first of all, I did some pre-processing on the formula. All right, I did some pre-processing on the formula, and the pre-processing I did on the formula is the following. I said, wait a second here. It's better to think of this as the square root of minus parentheses x minus 9, all right, minus 3. And the reason I did that is because, well, we'll see as we go on here. Y equals the square root of x minus 9. Right? So what that does is it shifts the graph, what? Over 9, right? So now that point is 9, 0. So we shift right 9 units. All right, now what? Well, I don't have x minus 9 for my formula, right? I've got 9 minus x, right? So that's a reflection across the y-axis, rather. Huh. Just a second here, guys. Excuse me. I actually don't like the order of my steps here. Can we switch it up? Switch it up. Let's switch it up. So what I want to do, for whatever reason, I can't see past this step right now. I don't know what's wrong with me. But here's what I'm going to do. I'm going to take a step back, and then I can see it for whatever reason. So take a step back here, and I'm going to instead, I'm going to kind of flip the order of the steps over here. And now I'm not sure if this is an insurmountable difficulty that I'm having in my mind right now, or if it's just the blind spot in my mathematical thinking. But how about this? Let's replace this with minus x, right? Square root of minus x. Now what that does is it flips this like that.
So
Yeah.
if it was y equals negative square root of x, it should be the other way, right? Go over the x-axis.
Y equals negative.
Negative square root of x.
If the minus is out front, it flips it. Yeah, the minus, exactly. If we had y equals minus the square root of x, that thing looks like this. Yeah, there's a very big difference between inside and outside for the square root. If it's inside, that means the domain is negative numbers. Because, you know, this only, this x, right, it would have to be like negative or 0 for the square root to be real. Anyway, the bottom line is if you replace x with minus x in your function, this is under the transformation list. This is like number 6 in the list. You flip over the y-axis like that. So I'm going to make that my step number 2. So you can, basically I'm switching steps number 2 and 3, for example, 2. I decided to flip the order there. I just can see it better. See now, if I look at y equals the square root of minus parentheses x minus 9, now I know what to do. I'm taking the previous graph, right, and I'm replacing the x in that function with x minus 9, which means I take step number 2 and I shift 9 units to the right. So it just looks like this, basically. And this is now 9, 0. Does that make sense? And then what? The last step is easier. Well, it's easier for me. I don't know. You guys are still learning, right? So we go minus 3. That means we shift down 3. So this 9, 0 shifts down to 9 comma minus 3. And oops, it's idiots. My bad. Something like that. I'm cheating a bit because I happen to know that this graph also goes, the finished product here goes through where? Try plugging in 0, what do you get? Plug 0 into the formula, you get square root of 9 minus 3, which is 3 minus 3, which is 0. So I happen to know, because I made this example yesterday, that this graph actually does contain the origin. So anyway, this is roughly speaking the picture of the graph. To be fussy, it should be a little bit more like this. It has a kind of a, it should kind of be steeper here, a little bit more bowed out. But so the last graph is the answer, basically, okay? So like the answer, well, to be fair, in these problems, if I ask you to graph by transformation, every part is the answer, right? The process is the answer. But what we're after is the last frame. So, yep.
Can you graph it in order of the steps that you have on there?
Yeah, that I don't know. I mean, I guess
All of those steps had.
it worked fine for you?
No, it's a different graph than the way you did.
Yeah, I'm not sure. Well, the thing that makes it hard for me is I shifted 9. Right, that would be like this. The thing is, going from here to that, it's not, that's not, this, so the relation of this to that, it's not a reflection across the x-axis, right? So, how can I say this? If we went from here to like y equals the square root of minus x minus 9, that would be a different thing. That one would look like this, I think. No, that's not right either. Sorry, let me stop that. That's not helpful. So the question is, if you got to this as your starting point, right, then how do you understand going to here? Oh, I'm sorry, and I'm an idiot. I haven't done I flipped it over, but I have no right to do that in this step, right? So going from here to here, I just shift right 9, right? Then your question is, how do you get from here to there?
If you put it over the y-axis, wouldn't it be, what kind of sort of negative 9, 0?
Flip it over the y-axis.
Because the negative is inside the function.
The thing is, this is equal to the square root of minus x plus 9, right? So in order to flip it over I can't flip this. If I flip this over the y-axis, this just becomes y equals square root of minus x minus 9, all right? Which is this thing. Right? That's what this would be.
So, based off of what we're given though, if we weren't even given the steps, how would we know how to go about that?
Well, I think if I gave you the steps that are in example 2, it would be unhelpful. I'd have to throw the question out. I don't think my steps are right. The steps as given are not right, is my point. Now, the steps that I have up here, I think are good. So how could you fix this? You'd have to anticipate, instead of shift, so what I would have had to have done is, fine. Let me, I'll try to fix it. So if instead of, I guess instead of alternate steps. All right. Number 1, y equals square root of x. Number 2, y equals square root of. I'm going to do an alternate. Like again, what I have on the board right here, I think is most natural. After thinking about it some more, but let me show you another path which I think is unnatural, but is another path. So we could do x plus 9. And then step 3 would be y equals square root of minus x plus 9. And then step 4, shift down. So I'll show you how those 4 steps go. So step number 1, same as usual, start with the square root. Step number 2, we shift 9 units to the left. Step number 3, we reflect across the y-axis. See the thing is, I have to go from the function before to the function after by merely changing x to minus x. That was my conceptual error when I wrote up the worksheet. I was thinking I'd done that, but I didn't, right? In what I've given you on the worksheet, I haven't just switched x to minus x. I've switched the pattern to like minus the square root of the thing, but I actually have to follow the x. So this going from here to here, all I've done is changed f of x to f of minus x, right? The 9 stays the same. And so that means that going from here, so this is 1, this is 2, this is 3. Going to 3, I just take the graph that's given and I flip it over the y-axis like that. So I go from minus 9, 0 to 9, 0 like that. And then finally, I shift down 3. And as you can see, the answer is the same, right? It should be the same if you can come up with there's not a unique set of steps which gets you to the end product, right? But what you have to do is to find a set of steps where each step you can do correctly. For me, I think the upper series of steps is more natural for this problem. That's all. So there's a good reason for me to make you make up your own steps, so I don't give you a wrong series of steps to try to flesh out, right? Yeah.
So how do you know that it's like going to be 0, 0?
Oh, because that's the fun. I mean, how do I know 0, 0s in square root graph? That is part of the thing that's part of what I mean by standard example you need to memorize. Oh. That is like knowledge that we have that we want to use. But more to the point, to answer your question, just without giving you a soapbox about that's something you need to memorize, the answer is square root of 0 is 0. So that's why 0, 0 is on there. Just like there's 1, 1 up here too, because like square root of 1 is 1. There's a 4, 2 up here because the square root of 4 is 2. I mean, you can always add points to your remembered graph by going back to y equals f of x is how we get x and y for a graph, you know. So example 3, I hopefully my other series of steps will not be in error. Ooh, goodness. I mean, I think that was good in the sense that we got to see 2 different paths to the answer, right? But all right, here we're looking at y equals to 3 plus 1 over 2 minus x. I say it's helpful to rewrite the formula. See, now I'm really suspicious of when I say it's helpful to rewrite the formula. 1 over x minus 2. I'm like, is it though? Did I actually do it? Okay. Oh no. I will get my confidence back here. Just give me a second. So we begin with the reciprocal graph, right? Start this guy with the reciprocal graph. Agree? This is a 1 over x kind of problem. So we start with the reciprocal graph, which looks like this. What's my next move? I keep looking. Oh, here it is. I said shift right 2, so y equals x minus 2. Now for the reciprocal graph, the thing you want to track is not a point. The thing that matters is the asymptote. Track the vertical and the horizontal asymptotes, right? So I'll do the asymptotes in a different color so you can see it better, all right? But the asymptotes here are this, right? So we're shifting right 2. Shift right 2. That does nothing to the horizontal asymptote, does it? But the vertical asymptote moves 2 to the right. So we got like that. And then what? Then I said we reflect across the y-axis, right? So we got y equals minus x minus 2. So all of the operations are always done with respect to the previous step. That's the key idea here, right? One step at a time. So we're reflecting across the y-axis. What happens to the horizontal and vertical asymptotes when you reflect them across the y-axis? Excuse me, across the x-axis. Nothing happens, right? They just turn back on themselves, all right? But the graph, on the other hand, it flips. So this guy flips up to here, and that guy flips down to there, like that. And then what? Oh, translate up 3 units. So translate's another word for shift. So when we go up 3 units, what happens to the vertical asymptotes? What happens to the horizontal asymptote? So I think nothing happens to the vertical asymptote, right? You move a vertical asymptote up and down vertically, nothing happens. It just stays put, right? But the horizontal asymptote, on the other hand, it goes up 3 units, right? So this technically should be at 2. This one should be at 3 if I'm being fussy. And otherwise, the graph shifts up. Like that. Like that. Something like that. Does that make sense? Step at a time. Oh, did I forgot to ask you, did you pan over to my, you already got that one? You already got over here? Okay, cool. All right. Example 4. Here we're looking at y equals to 2 times x minus 3 squared. So here I don't even need all 4 windows, right? I can make do with 3. So what's the basic graph? Just x squared, right? Yeah, it's a parabola. Y equals x squared. So that one is, this. And then what am I doing? So if we replace x with x minus 3, what happens? We move 3 to the right. And so I'll track the vertex here. So that one moves over here to 3, 0, right? And let's see here, something like that. And then I add the 2. Yep. What's that do? Right. So if I want to be careful, about the stretching, I need to follow like 3 points. Okay. So let's try to do that. Let's track the points 1, 1, and also the point minus 1, 1. Where do those go to? Like 4, 1, and this one is 2, 2, 1, right? And then what? And then we're stretching by 2, right? So what's that do? What happens there? This point stays the same, because if we multiply 0 by 2, it just stays put. I'll find the right color eventually here. So this guy stays put. All right, the vertex stays straight where it is. But these 2 points, when we multiply y value by 2, the x stays the same, right? But it goes up. Instead of 4, 1, it goes to like 4, 2. And instead of 2, 1, we go to, 2, 2. So it's stretching means it's getting more like that. So it was more wide before, now it becomes narrower. Listen, to do the stretching and compressing justice, I really need to give you graph paper, right? So you can kind of see it better. But I also didn't want to, I also wanted these templates to be sort of uncluttered, which is why I didn't want to put the graphs on there. So I'm kind of torn between 2 concerns, which is, I have some graph paper that's got tiny little divisions, but that's distracting for another reason. So, but yeah, anyway, yep.
Plot the points for when we're stretching the graph. Are we plugging in the x coordinate for all the points and getting the y value?
So it doesn't, so this multiplying the formula for y just changes y, right? So the x coordinates are staying the same. We're just multiplying the y by 2. So like this multiplied by 2 goes the 4-1 becomes 4-2. The 2-1 becomes, sorry, I didn't label it, 2-2. So we're just changing the y values, if that answers your question.
Thank you.
Uh-huh. What's that?
How do you know that you're just changing the y values because it's on the outside?
Yeah, because it's multiplying the y by 2. Yeah. Anyway, I would encourage you guys to try the other 2 examples here. If you want to see me work them, if you watch the video from another section, you'll see me work them. Because I got hung up on example 2 here. It hurt my flow. So anyway, you guys have a good rest of your day.